Yeah, hi everyone. My name is Alexey Adamovskiy. I was working for many years as a full-stack Java enterprise developer, but finally a few years ago transitioned to JavaScript and now work as a founding engineer at Ogment. At Ogment, as Malik said, we empower companies with fancy modern AI tools, and the fanciest, the most modern AI tool is MCP. So the first question before we start, does anyone actually use MCP or was trying to build one? Okay, cool. So for those who have never tried and never heard of that, MCP is a kind of plugin system for your LLM clients, for ChatGPT, for Claude, and so on, for Cursor. It's an open source protocol that allows your server to interact with the client in agentic mode. That means something like how Cursor works when you or any other vibe coding tool. When you put a request in there, it does not respond to you right away. It can think a little bit around. Call other third-party systems and give you the answer after iterating. So you can do the same with ChatGPT or any other client by connecting various MCP servers. So the main question is why you should care about that. Here's a simple example from our actual customer who are not super technical people, but they managed to connect a simple MCP server for database with market knowledge database. And now they do not need to write SQL queries, but they can query database in natural language. And for your development process, you can imagine adding, for example, to Cursor, adding Sentry MCP, adding bug tracking MCP, and not just vibe coding, but vibe fixing bugs. So you can have the entire development process inside your ADE, and you don't need to switch to different other systems. And yes, you can run Doom on MCP. So what is MCP under the hood? It's actually pretty simple, despite so much talks around it. It's pretty simple protocol, at least nowadays, which basically exposes three types of entities: tools, resources, and prompts. And to be honest, tools is the main one that you're probably going to be building if you will be building an MCP server. Essentially, it's very similar to just API endpoints when you define some handling logic and you expose that handling logic to LLM client. So LLM client connects to with an HTTP stream with server-side events. I will cover later what is server-side events and why do we need them. But it's the important fact that it's bidirectional connection that calls some tools. Resources and prompts. And the message that is sent over that connection is pretty simple. It's just simple JSON RPC like this. This is an actual request that calls some tool, I think, I don't remember. And the third big part is authentication. If you publish your MCP server, you will probably need to have some authentication. And regular OAuth is a part of the protocol. So you are able to reuse your existing OAuth server for that. So how to build an MCP? You first you need to choose your language and choose the SDK. Two most popular ones are Python and Node.js. So you take an SDK, you define a server with some metadata like server name, description, maybe some version compatibility information. Then you define tool handling logic in this example is just addition tool. And that's all. You have your MCP server, really. And that's all you need if you need to show a demo or you need to show some proof of concept. But if you want to have a really useful MCP server, at least for yourself, you need to consider more things. First one is client capability. This MCP world today looks very similar to early days of web, when you need to be compatible with every browser specifically. So right now, if you want to be 100% compatible with all clients, you can use only tools. As you can see, there are other features that are not supported a lot. But you can come up with some reasonable trade-off and decide which clients you wanna support. And you can also add an initialization step, which allows you to interact with the client and come up with a common subset of features that you both support. And even if some clients do not support some essential features, you can just adjust the logic itself, because you have the information about which exactly client is using your server, which features it supports, and so on. That is very useful because clients are very, very different. And not all of them strictly follow the protocol. So I will show more about that later. But one interesting subset of client capabilities that are usually not covered with those three items are update notifications, sampling, and elicitation. Update notifications are those server-side events. It's a way for your server to initiate communication. For example, it's similar to like push notifications, for example. So, for example, you can have a dynamic tool list depending on the context. Or you can have a resources lifecycle. For the example, you can have an e-commerce system, and a resource might be an order. And you can notify your customers ChatGPT about order being delivered, lost, or anything else. And sampling and elicitation are pretty similar. It's for your server to be able to reach out to the client and collect some additional information. The difference is sampling is when your server interacts with client's LLM without even including user in this conversation. So it's a way to use client-side LLM. And elicitation is just a prompt, for example, for the e-commerce example, your server might ask for delivery address for the order. And unfortunately, almost no clients support those features yet, but they are already in the protocol, so hopefully we can expect they're going to be there soon. Another nice feature that is not even a part of the protocol right now is UI. There is a project called MCP UI, which is an idea of how to extend the MCP protocol to include some UI pieces. Technically, it's pretty simple. It returns a piece of HTML code as a part of a to response, where you can use SDK to interact with the entire, with the outer client, and you can draw a nice diagram like this. Unfortunately, this MCP UI is more of a proof of a concept. They have a set of React components to build your own web client. But most likely, if you want to reach out to customers, we want to be compatible with ChatGPT, Claude, and other popular clients. We don't want to build our own. Because if we build our own, basically, we don't really need MCP. We can provide all those capabilities as custom tools. Recent ChatGPT release actually adopted something very similar to MCP UI, and now you can build something like this example, because this is a real Booking.com MCP server that allows booking to display some widget right inside ChatGPT. So I personally think that this is going to be a really big change. So another unfortunate about clients is the amount of bugs. You can see those 4,000 reported issues in the official Claude code client. To be fair, it's not all about MCP. It's generally about Claude client, but all those clients are like, you cannot rely on them. You need to test each client separately and make sure that your specific server works before like delivering it to someone. And this is how protocol evolves. It's also changing rapidly, and you can see like 200 comments, discussions about how to like do the next step in the evolution of the protocol. So you need to be prepared that technology is raw, and you will need to update it. You will need to keep tracking changes, and yeah, test. Business logic is also challenging. You have two main challenges for implementing your MCP server's logic. First one is the user is not actual user, is LLM. And unfortunately, it's not a human. It has some restrictions. The main one is the context window size. So natural idea would be to put everything you have, like all the information you have to the output, put it into LLM context and hope that LLM is smart enough and it will figure out the answer. The truth is it's kind of opposite. So the more information you put in there, the dumber LLM, it loses more and more details and generates more hallucinations and so on. So you need to be smart about the format of the output, about what to not include into the output and so on. So like engineering the context is, I guess it's the biggest challenge when you want to build some useful MCPs. And the second one is still hard to find the right usage scenario. It's very new, and right now we basically have two good examples of when to use MCPs or tools. It's when you drop some documentation into the context and when you add search capabilities into that. And essentially, this is how vibe coding tools work. They add to your model ability to search across your repository, and they know something about like tools and libraries you are using. And actually sometimes you just don't really need an MCP server. That is surprising in 2025, but yeah. But sometimes you need to spend a bit more time, figure out the actual use case and get 10x performance. So I guess it's worth exploring. Third part of MCP server implementation is evals. Like with unit tests, you need to make sure that your server works, with the difference that LLM is non-deterministic, and you cannot just run a test once and make sure that it works or it doesn't work. It will be like working to 80% of the time, for example. So you will need to prepare a set of prompt examples that your users might submit. You need to have some runtime to run it against different models. And again, you will need that because even if you rely on one model, they have versions, and it can easily be like, it can easily break in the next version of GPT-4o. Yeah, and you will need to define assertions somehow because the output is also non-deterministic. So you will need probably another LLM call to ask it like, hey, is this output reasonable or not? Evaluation platforms are the modern hot topic. There is a lot of new startups who are building something like this. And this example is our Ogment evals. So to summarize, to make a usable MCP server, you need to align with client capabilities. You need to define business logic and prepare some tests for that. That's enough for you to use an MCP server yourself. But if you want to share it with your colleagues, first thing is transport. Actually, hello. There are two available transports, and if you build just for yourself, you only need std.io. That means you run the MCP server as a local process, very simple, nothing can go wrong. You just run a JavaScript. But if you want to share it, of course, you need to wrap it into HTTP. And if you already have an existing std.io server and you just wrap it, something can go wrong because std.io is naturally single-threaded, and HTTP server is usually like handles concurrent requests. So it's going to be enough of 2 users to have a failure because one will submit a heavyweight request, another will try to connect, and if that user who tries to connect is using Claude, Claude has a bug when like 5 seconds delay will put the entire client in a broken state. So again, you need to test with the specific client. That's the history of my previous week. When you created an HTTP server, you need to make sure you delivered it to your users. It's cool if your users are developers, but if your user is a sales manager, let's say, you can imagine explaining to a sales manager to find a JSON file in a file system and put something like this in there, like providing his private API key. That's just not doable at all. So usually it's nice to have a set of install guides explaining how to connect different clients. Fortunately, now Cursor has one-click deep links where when you don't need to provide any configuration, you just click and install. And most of clients right now support just one URL configuration if you have a proper remote HTTP server. Since you have an HTTP server, you need to have some hosting, and there are plenty of options. Of course, you can do it yourself, rent a VPS, run a Docker in there, or do it in a cloud, or do it in a Cloudflare worker. But it's better to rely on some specialized tool. There is a lot of MCP hostings as a service, like Ogment, Alpic, Smithery, and others. They are basically hostings for little Docker images. When choosing one of them, you need to look at additional features that they provide. Or you can go and run one of open source MCP gateways locally. They also have different sets of features like authentication, various capabilities support. And hosting usually provides you with vertical scalability when you need to add more hardware resources to your server. But for horizontal scalability, you will need to make a decision because there are 3 options. Option 1 is do nothing, run one server, and hope that it will work. And it will probably work until you will get the second user, or until you will get someone who will decide to try how much of a high load your server can handle. So you will need to come up with one of 2 options: either create one separate server per request, or create one server per session. And while doing so, you need to also remember that not all of those servers that are out there on GitHub are very good. And for example, if you are using BigQuery server that I showed on the previous screenshot, it looks very simple and feels like you don't need much of resources to have a little proxy to API. But Python library buffers all the outputs, and if you have a large output, you have technically memory leak. So pick one of those. So to make it shareable, you need to support HTTP transport, prepare setup guide for your customers, host a server somewhere, and make sure that this hosting is scalable. But if you want not just share it with your colleagues, but let's say sell it or make it part of your business, deliver it to your customers, you will need something else. First thing, of course, is authorization. So there are few examples of simplified authorization in existing servers. One is if when you provide a token in URL in query parameters of the URL of the MCP server. So as you can imagine, it's a good way to make sure that your customers' credentials are somewhere in logs. Another option is to put token to tool parameters or have login as a separate tool, but that means your customer's credential will go through LLM, and that means they will participate in the next round of training somewhere in OpenAI, and you will have nice code completion for your password. So the right option is to use the actual OAuth protocol, which is again not so complex, and there is plenty of providers, and you just need to have three features enabled in your provider. You will need tracing and monitoring, and it's also not a part of the protocol, so you will need to come up with something like regular, like Sentry, Datadog, OpenTelemetry. This image is an example of a distributed transaction that we have. It's pretty convenient to have them as distributed transaction. The view is similar to specialized tools like LinkFuse, for example, if you are familiar with that. But in case of MCPs, it does not make much sense to use LinkFuse because you do not control LLM. You only provide tools, and LLM works on the client side. You need to handle client-specific headers because ChatGPT, for example, does not give you client IP right away because it's running on OpenAI's backend. But it provides user ID and other user-specific parameters as HTTP headers. Again, it's not standardized, so you will need to handle per client. For configuration, there are multiple options, possible options. The simplest one is just configuration as environment variables and the script parameters. When you cannot change it in runtime, you don't have nice interface for your customers, but you set it up once and hope that it's going to be enough. Second option is a nice UI of Supabase, which allows you to generate a custom URL where parameters are query parameters. And third one, the most advanced, is when you have some web app which allows you to go to your browser, prepare some configurations, and then when you will be logging in into an MCP server, it will let you pick the right configuration profile that you will be using. This is how Smithery works. This is how Ogment works. Discoverability is one huge emerging topic. For that, you have at least marketplaces, I think, in all gateways and hostings, which can have some review to get in there, or you maybe can register without any reviews, or it can even scan GitHub and find your MCP server without even asking you. Usually, you need to provide some JSON configuration, JSON metadata file in your repository to make it easier for the scanner to find it. But recently, ChatGPT announced this context-based auto discovery, which is probably going to be the future, when we're going to have something similar to SEO, which is already called GEO, Generative Engine Optimization. And we will be optimizing MCPs the same way we optimize websites. And speaking of SEO, there are few ideas how to replace sitemap XML for MCP, but no standard yet, so you will need to support everything to make sure you will be searchable. So to productionalize your MCP server, you need to connect some auth provider, add tracing, monitoring, configuration, and decide on how you're gonna be discoverable. And Ogment is helping with most of what we just discussed. It has a nice no-code MCP builder where you can convert API to MCP, where you can mix and match multiple existing MCP servers into one. You can add monitoring, evaluations, authentication, like user management, and of course, everything is scalable hosting with MCP catalog. Thank you.
Unfortunately, we don't have time